Alright, here we are, section 3.3, solving quadratic equations. This time we are using the square root method. Now this one's pretty straightforward. The first thing you want to do when you look at a problem and you have to solve using the square root is isolate whatever term or set of parentheses that's squared. So for example, right here, x squared is right there. So everything else we want to move to the other side of the equal sign. And we can start that by subtracting, subtracting 23. I'm actually going to jump up here, not a lot of room, so 2x squared equals 5 minus 23 is negative 18. And again, we want to get x squared by itself, so we need to get rid of the 2. We can do that by dividing both sides by 2. X squared will equal negative 9. And then, once you have your squared term isolated, you want to take the square root of the left side and the right side. On the left side, what that's going to do is it's just going to cancel all of this out, so you're just left with x. And then on the right side, if it's easy, like the square root of negative 9, you can just tell me plus or minus 3i. Don't forget the I because of the negative sign. Or, if it's not quite so easy, you're going to have to use a factor tree to break it down and look for pairs. So we'll do maybe one or two more here. The idea is still the same, so you got to look for whatever's being squared. In this example, number 2, this whole x minus 3 part is what's being squared. So that's what we want to isolate first. So the 8 and the 2 have to move over to the other side using inverse operations. Starting with subtracting 8. So 2, and we still have x minus 3 squared equals negative 8. Again, this is what we're trying to isolate first. So we need to get rid of that 2. We can do that by dividing both sides by 2. X minus 3 squared equals negative 4. So now we have our term that is being squared. It's isolated now. Here's where we introduce the square root on both sides. And again, what that's going to do is it's going to cancel the square and the square root, and it's just going to leave us with x minus 3 equals. Now on the right side, you're always going to get plus or minus, and now in this case, the square root of negative 4 is pretty easy. It is 2i, but again, if you don't know that, use a factor tree, break it down into prime numbers, and look for groups of 2. And then, so we're not quite done. We want to solve for x. Not x minus 3 in this example. So what we need to do then is add 3 to both sides. We'll hop over here. So then what we're going to have is x equals. Now the proper way to write this would be to put the positive 3 first and then plus or minus 2i. It's always the real part and then the imaginary part. That would be the correct way to write your complex number as an answer. All right, we can do one more here. So here is our squared term. It's just x that's being squared. So we'll start by subtracting 17 from both sides. Negative 4x squared equals negative 36. Okay, so we want to get rid of the negative 4. We can do that through division again. So x squared equals 9. And then, so we have our term that was squared isolated. So now we introduce the square root. Get rid of that. Take the square root of the right side. So now x equals plus or minus 3. Okay, pretty straightforward. There is one more that we could do, but it looks just like example number 2. There's a 3 here for you to do. Actually, technically 4 since the last example has 2. And that is it.